Hello everyone, welcome back to Code with Cougar. In this video, we're going to write a Python program to convert a given binary number to its decimal form. So let's first understand what a binary number is. A binary number is made up of only zeros and ones. So the base of the binary number is 2, means that we can only use two symbols, either 0 or 1 to make a binary number. So this is a binary number. Its base is 2. We can use only 1 or either 0. This is an example of the binary number. Whereas in a decimal number, we can use 10 symbols from a 0 up to 9. That's why the base of a decimal number is 10. So if we are given a binary number like this, how can we find what is this equal to in decimal? So let's first understand how a binary number is converted to decimal. Then we can write a Python program based on that. So let's take this example. It's if we are given a binary number like this 1010, to convert it to decimal form, so the decimal form of 1010 is 10. How can we convert it to the decimal form? First, we are going to take the first digit of the binary number. We multiply that to 2 to the power of 0 for the first digit. Then we go to the right and take the second digit and multiply the second digit to 2 to the power of 1. Then we take the third digit of the binary number and we multiply that to 2 to the power of 2. We go further and take the fourth digit of the binary number and multiply it to 2 to the power of 3. And we sum up all the product of all these and that's going to give us the decimal number of this binary number. So remember, as we go from right to left, we start from 2 to the power of 0. As we go further, the power of 2 increases by 1. So first we have 2 to the power of 0, then 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. If we look at another example, suppose this one is given a longer binary number. Suppose we are given this binary number. So the procedure is that we are going to take the first binary digit and we multiply it to 2 to the power of 0. And finally, we sum up all the results. That's going to give us the decimal number of the binary number. Then we take the second digit of the binary, multiply it to 2 to the power of 1. And each time we iterate, we increase the power of 1 by 2 until we reach the last digit of the binary number. And we multiply that to 2 to the power of 7. In this case, so we iterated 7 times. Finally, we add up all these results: 1 plus 2 plus 0 plus 8 plus 16 plus 0 plus 64 plus 128. That's gonna give us 219. So the decimal form of this binary number is going to be 228. So this is based on base 2 and 219 is base 10. Sorry. So let's write a Python program to convert this given binary number to decimal form. So let's open our IDE and prompt the user to enter a binary number. We can store the binary number in bnum or binary number equal to int. Since input function returns a string, we gotta cast it to integer. Input enter a binary number. Let's define a couple of variables. We gotta have a d number or decimal number equal to 0. So what basically decimal number or d number used in our program? If we look in this diagram, d number is used to store the sum of all these results we get in each iteration. So 1 plus 2 plus 0 plus 8 plus 16 and so on is going to be stored in our dnum variable. Then we will need another variable rem or remaining equal to 0. So each time we gotta take the binary number and divide it by 10 and we take the remainder. That's gonna give us the first number. To store the first number, we use the rem variable in our program. Excuse me, the rem variable. Then we need another variable I equal to 0. So basically I is going to store I represents the power of 2's. So here we have power of 2's starting from 0. In each iteration it's incremented by 1. So we are going to represent this power of 2's by 1 in our Python program. So then using a while loop, we are going to iterate until we reach the end of the binary digits, while bnum not equal to 0, while we have not reached the end of the binary digit. So first time we take this number, second time we take this number, this number, this number, until we reach the end of the binary number. So while we are not at the end of the binary number, or bnum is not 0, we take the remainder, rem equal to bnum modulus 10. So basically it's going to take the first digit and store it in num variable. If we divide this by 10, it's gonna give the remainder as 1. So this one, or first digit, is going to be stored in rem variable. Then we are going to take this rem variable and multiply it to 2 to the power of 0 and store the variable in dnum. So dnum equal to dnum plus rem, which stores the first digit of the binary number, into 2 to the power of 0. We use the pow function, 2 to the power of I. So our I is 0 here. So basically we took the first digit and multiplied that to 2 to the power of 0. For the second round of iteration, we increase the power of 1 by power of 2 by 1. So we increase I by 1, I plus equal to 1. So we took care of the first digit of the binary number. So for the next iteration, we are going to take this one as first number of the binary. So to do that, we gotta divide this whole binary number by 10. So that will get rid of this number, and the second round of iteration, this one will be our first digit. For the second, we further divide this by 10, and this will get rid of this number. And for the third iteration, 0 will be our first number, or first digit. So let's divide that bnum equal to bnum divided by 10. So if I show you in calculator, suppose the user enters 1010. So for the first round of iteration, we took this 0 and we want to get rid of that. So to get rid of that, we divide this whole number by 10. If we divide it by 10, we can see that the 0 is gone. So right now our binary number is 1010, and 1 is our first digit. To get rid of this 1 in the second round of iteration, we further divide it by 10. If we divide it by 10, it gets rid of the 1, and our binary number is now 10. So we don't want the floating point. So to store the integer form of this, to store only 10 and get rid of this floating point, we use the double division in Python. So we gotta use the double division. What basically the double division in Python does is it will divide this first number by the second number, and it will take the floor of that number. If I give you an example here, suppose we have print 10 divided by 3. This is gonna print it in the decimal form. And if we divide print 10 double division 3, this is gonna print only the decimal form, and it will ignore all the all the floating points. So if I save my program and run that, we can see that a single division takes or prints the floating point numbers also, but the double division ignores the floating point and also only print the integer value. So we want to store the we don't want to store the floating point back to b number, so that's why we use the double division in our program. So let's get rid of that. So the next round of iteration, so the first digit will be ignored and the second digit will be our first digit, so until it becomes 0. That's it, guys. Let's at the end print our d number, or decimal number equal to d number. I hope everything is correct. Let's run our program and see. If we run our program, enter a binary number. If we enter 1010, it should give 10. Okay, decimal number is 10. And if we enter this number, it should give 219. 110, If we enter that number, it should give us 219. Let's rerun our program. 110, Yeah, we got 219. So this was a simple program on how to convert a binary number to its decimal form. Hope you guys have learned something, and please don't forget to subscribe to Code with Cougar, and see you in the next cool video.